Stoichiometry, chemical calculations of reactions. Hello class, before we begin, please ensure that you have the following relevant materials. Okay, you will need Notes Chapter C, Stoichiometry, chemical calculations of reactions, a calculator, and the periodic table. All good? As usual, the top will show the page number and the subtopic. If you see any underlined words, fill it in your notes. Any highlighted words, you may highlight them. And if you see any scribbles or red words, you can add them on to your notes. Let's go. So far, we have covered what is a mole, the relationship between mass and mole, and the relationship between volume of gas and mole. Those were just the basics. Now we move on to word problems, as I would like to compare them, where we calculate mass or volume of substances when we are given the chemical equation. Okay, this is called stoichiometry. Right, turn to page 1 of your notes. We are going to have an analogy of a recipe to a chemical equation. Right, let's say I want to make one chicken and hamburger, and the following are the ingredients. Okay, we need one burger bun, 2 slices of ham, 1 slice of chicken patty, and so on. How many slices of ham and chicken patty must we prepare to make 5 burgers? If the ingredients was for 1 burger, how many will we need if we want to make 5 burgers? Right, simple mathematics would be, I would need 10 slices of ham and 5 slices of chicken patty. Similarly, a chemical equation is like a recipe. Let's see here, I have 2HCl plus MgO, and I'll get MgCl2 and H2O. Right, this is a simple neutralization reaction. A chemical equation tells us what substances react together. These are called the reactants. For this equation, HCl and MgO are the reactants. The chemical equation also tells us what substances are produced. Okay, these are what we call the products. For this equation, MgCl2 and H2O are the products. And lastly, the equation also tells us how much each substance is required. And that is what we are focusing on today. Right, if we are given the equation, how much do we need for each substance? Turn to page 2, the mole ratio. Consider the chemical equation. 2 of hydrogen, H2, plus 1 of oxygen, O2, will produce 2 of water, H2O. So what does it tell you? How many of each substance do we get? Okay, the equation tells us, we need 2 of hydrogen gas and 1 of oxygen gas to produce 2 of water. Right. I can also say, if I have 2 dozen of hydrogen gas and 1 dozen of oxygen gas, I will produce 2 dozen of water. I can also say, if I have 200 of hydrogen gas, 100 of oxygen gas, I will produce 200 of water. Alright, as long as the unit is a unit of counting, dozen, hundred, million, okay, the ratio still remains the same, 2, 1, 2. So furthermore, I will need 2 moles of hydrogen gas and 1 moles of oxygen gas to produce 2 moles of water. As you have learned, moles is a unit of counting, okay, for a large number. The ratio remains the same. Alright, important. The coefficients in a chemical equation refers to the mole ratio of the substances. Okay, coefficients being the number in front for each chemical substance. So in this case, the coefficient for hydrogen is 2. How about oxygen? Okay, oxygen doesn't seem to have a coefficient, but you learn that it is actually 1. So you can write that down. So the coefficient for oxygen is 1. And of course, the coefficient for water here, H2O, the number in front is 2. Alright, so in this case, the mole ratio of H2 is to oxygen, O2, is to water, H2O, is 2 is to 1 is to 2. Right, so this is considered the mole ratio. 2 is to 1 is to 2. So, if I have 4 moles of hydrogen and 2 moles of oxygen, how many moles of water will I produce? Okay. Since the ratio is the same, I would get 4 moles of water. Okay, you can write down the ratio here. 2 is to 1 is to 2. If I have 3 moles of oxygen, okay, how many moles of water can I get? Okay, think about it. What is the ratio of oxygen to water? Okay, if I have 3 moles of oxygen, I can get 6 moles of water because the ratio of oxygen to water is 1 is to 2. And if I want 0.5 moles of water, how many moles of oxygen do I need? Okay, I will just need 0.25 moles of oxygen because the ratio of water to oxygen is 2 is to 1. Alright, now would we be able to calculate the mass of substances obtained and required? Recall, okay, you can use the formula triangles to calculate the mass given the number of moles or to calculate the volume of gas given the number of moles. Right, so please copy down the formula triangles in the space. Okay, the next section is very important. So I hope that you can focus. Alright, it is something new. So if you need to pause and think about it and rewind, okay, take your time. Okay, but you need to focus to understand this new section. Alright, page 2, example 1. Calculate the mass of water produced when 0.5 grams of hydrogen gas is burnt in oxygen. Okay, then we are given the equation. Okay, it's the same equation as we have been doing for the examples. Okay, now I have a question for you. Can I say since the ratio of hydrogen to water is 2 is to 2, which is the same as 1 is to 1, and 0.5 grams of hydrogen is burnt, so 0.5 grams of water is also produced. Okay, I repeat again. Since the ratio is 1 is to 1, if I use 0.5 grams of hydrogen, will I also get 0.5 grams of water? Okay, think about it. Okay, the answer is actually no. Right, please remember, the coefficients in the chemical equation refer to mole ratio, not mass ratio. Since 0.5 grams is for mass, we need to convert the mass to moles first. Then we can use the mole ratio. So mole is a number. It is not a mass. So you can have the same number of things, but those things can weigh differently or have different masses. Same like this. Okay, the ratio is 2 is to 2 or 1 is to 1. They have the same number. Okay, but they will have the same, they have the same number, but they will have different masses. Okay, because one is hydrogen and one is water. So I repeat again, the coefficients refer to mole ratio, not mass ratio. We will need to convert the masses to moles first before we can use the mole ratio. Alright, so how do I solve this kind of questions? Usually I will rewrite the equation, giving a lot of space in between the substances. Okay, as shown here. So I will encourage you to do the same. Alright, then I will highlight or underline certain key information from the question. Example, 0.5 grams of hydrogen. Okay, this is an information which is given in the question. So I will then write it below the equation that I just wrote. Then I also want to know what I need to find out from the question. Okay, the question asks me to calculate the mass of water. So this is what I need to find. So I will always write question mark. And since I want to find the mass of water, I write question mark grams. Okay, so remember, mass is unit of grams. And the next few steps is what I'm going to call the junction method, because you are going to take the junction to go to mole first before you calculate the rest. Alright, so how many grams of water will I produce given that I have 0.5 grams of hydrogen? So as the junction method implies, I need to take the junction to go to moles first. So let's convert 0.5 grams of hydrogen. How many moles would that be? Okay, think about it. How to convert mass to mole? Right? Okay, and the answer lies in this formula triangle. Okay, to calculate the number of moles is mass divided by mR. And I divide the mR of hydrogen, H2. Please take note, I am not dividing the mR of 2H2. Okay, the 2 in the coefficient for hydrogen is for mole ratio. It is not part of the formula. It's like saying the formula of water is H2O. Okay, and I don't say it is 2H2O. Okay, the 2 refers to the mole ratio. It's just a coefficient in the equation. So 0.5 divided by the mR of hydrogen. So what is the mR of hydrogen? Okay, if you refer to the periodic table, okay, hydrogen is 1, so H2 would be 2. So it will be 0.5 divided by 2, and I'll get 0.5 moles. Alright, next. Now I have moles, so I can use the mole ratio to compare how many moles of water do I get. Okay, so we need to use the mole ratio. And the mole ratio refers to the coefficients of the substances in the equation. In this case, comparing hydrogen and water, we have 2:2, which you can simplify as 1:1. So if I have 0.25 moles of hydrogen and the mole ratio is 1:1, how many moles of water will I get? Okay, since the ratio is 1:1, I will also get 0.25 moles of water. Now that I have the number of moles of water, I can find the mass of water produced. So from moles, how do I convert to mass? Alright, it's similar to just now. Okay, now that I have the number of moles, okay, I can multiply by the mR to get the mass of water. So what is the mR of water? Okay, hydrogen is 1 and oxygen is 16. So total will be 18. So the mass of water produced would be 0.25 times 18, which is 4.5 grams. And that is the answer for this question. Okay, so copy down this working. Alright, it is like a flow chart for you to understand what is going on. So if I'm given any information, to use the chemical equation, I need to convert to moles first. Then I can compare using the mole ratio. Then I can convert back to whatever do I need, such as mass and sometimes even volume. So copy this down. Okay, understand it first. Okay, and once you're ready, we'll go through another example. Right, page 3, example 2. Calculate the mass of hydrogen chloride required to make 20 grams of magnesium chloride. As usual, I will rewrite the equation, okay, giving a lot of space in between. So, highlight or underline important pieces of information. So we have 20 grams of magnesium chloride. Okay, this is a given information. So I write it down. So what do we need to find? From the question, we need to calculate the mass of hydrogen chloride. So this is what we need to find. So question mark grams, because mass is grams. So given the mass of magnesium chloride, we need to find the number of moles first. Once again, we always convert to moles first. So how to convert from mass to mole? Okay, similar to the previous question, we divide it by mR. And if you use the periodic table, you will get the mR to be 95. So 20 divided by 95, I will get 0.21053. Right, correct to 5 significant figures. Okay, next. Knowing the number of moles of magnesium chloride, how many moles of hydrogen chloride will I require? Okay, so now that we have moles, we can use the mole ratio. So what's the mole ratio? Looking at the coefficients, all right, for magnesium chloride, okay, there is one of it. So the mole ratio is 2:1. So if 0.21053 represents 1, how many moles of HCl do I get? Okay, so I'll just multiply by 2. So in this case, I will get 0.42106. Right, yes, it's a large number, but it's okay, it's the same. Right, now that I have the moles, how do I find the mass? Same thing. I will multiply by the mR. So number of moles times the mR, I will get the mass. And the mR of hydrogen chloride would be 36.5. So 0.42106 times 36.5, I will get 15.36869. Alright, it's such a big number. Of course, this was rough working. Final answer should be in 3 significant figures. So the final answer would be 15.4 grams. Alright, so this is similar to the previous question, but the mole ratio is not 1:1. The mole ratio in this case is 2:1. So you need to multiply the number of moles accordingly. So write down this working, okay, and understand it. Then we'll move on to the next question. Example 3. Balance the equation. Okay, you're given N2 plus H2 to get NH3. Alright, we'll just simply balance this. Okay, there is 2 nitrogen on the left side and only 1 nitrogen on the right side. So we'll need 2 of NH3. Now we only have 2 of hydrogen on the left side and 6 hydrogens, because 2 times 3 for NH3, and I need 3 sets of hydrogen to balance 6. Right, simple enough. Okay, now calculate the volume of ammonia gas produced when 12 dm cube of nitrogen gas is used. So once again, rewrite the equation, giving a lot of space, okay, for the junction method. Right, so what is the important information in this question? Right, and that is 12 dm cube of nitrogen gas. This is the given information. So I have 12 dm cube of N2. And what do we need to find? Okay, we need to find the volume of ammonia gas. So this is what we need to find. So question mark, how many dm cube of ammonia gas? So this time we are dealing with volumes of gases. We are not dealing with masses. So from what is given, how many moles of nitrogen do we have? Okay, now can you remember from volume of gas, how do we convert to number of moles? Alright, it's actually this formula triangle. So to find the number of moles given the volume of gas, I will need to divide the volume by 24. And I'll get 0.5 moles. So given 0.5 moles of nitrogen, how many moles of ammonia will I produce? So now we will apply the mole ratio. Alright, there is no number in front of nitrogen, okay, but it is actually 1. So the mole ratio is 1:2. So if there is 0.5 moles of nitrogen, how many moles of ammonia would I produce given that the mole ratio is 1:2? So it's simply 0.5 multiplied by 2 and I get 1 mole. Now that I have the number of moles of ammonia produced, how do I find the volume of ammonia produced? And that is with the same formula triangle. So you multiply by 24. And that's the answer, 24 dm cubed. Right, so the volume of ammonia produced is 24 dm cubed. Right, so this is similar to the previous examples, but now we are dealing with volumes of gases instead of mass. So be careful when you are reading certain questions. Alright, before I let you all practice on your own, okay, I will go through one more example for you. Okay, since this is a new thing, alright, I will give you more examples so you can try the questions better later. Alright, so turn to page 5 of checkpoint 1, question 3. We have 63 dm cubed of carbon dioxide measured at room temperature and pressure was used to react with iron 3 oxide. What mass of iron was produced at the end of the reaction? Okay, so once again, I will rewrite the equation, giving a lot of space so that I can do the junction method. Alright, so what information is given here? Alright, the volume of carbon monoxide. So I will write it down. Then, what do we need to find? So the question wants us to find what is the mass of iron. So in this case, question mark grams. As you can see, we are given volume, okay, but we need to find mass. Alright, so it's actually the same thing. Alright, although there are different units, alright, the method is the same. We always go to the junction of moles first, then we convert. Alright, so given 63 dm cubed of carbon monoxide, how many moles is that? So for volume of gas to convert to moles, okay, as we have just previously covered, we divide by 24. And in this case, I get 2.625 moles. Okay, now given that I have 2.625 moles of carbon monoxide, how many moles of iron will I produce using the mole ratio? And in this case, what is the mole ratio? Right, the mole ratio is 3:2. So if 3 units represent 2.625, 1 unit is how much, and therefore 2 units is how much? So 3:2. Okay, if you use a bit of mathematics, right, 2.625 moles, okay, will produce 1.75 moles of iron. Now that we have the number of moles of iron, we can find the mass of iron. So what do we do? Okay, so as you have probably know by now, from number of moles to convert to mass, okay, I need to multiply by the MR. And the MR of iron in the periodic table is 56. Right, technically it should be AR since iron is just one atom, not a compound, but it's okay. I'll just use MR. So 1.75 multiplied by 56 and I will get 98 grams. And that is the final answer. Mass of iron produced is 98 grams. Okay, as you can see, this example that I show you, okay, although you are given different quantities, volume, and then you need to find mass. Okay, the common junction that everyone goes to is mole. So convert everything to mole. Okay, then use the mole ratio and then convert back to whatever quantity that you need to find. I'll give you some time to copy this now. Okay, once you're ready, we can move on. Alright, So try checkpoint 1 and the practice questions on pages 4 to 5 on your own. Okay, then you can check the answers later. All the best. Take care.